Welcome, Algebra 2 Honors students, to a video on, well, goats, first and foremost, but on applications of quadratic functions. Okay, that was a song called The Goat by a band called the Insteps, one of my favorite bands from when I was in high school. All right? So, this problem, I have it right here on the computer. It has all this stuff, which isn't so crucial, about Alima being a farmer and some barn. Okay, but what's important is that you understand what the problem is asking. It says, in particular, to letting x represent the width of the enclosure, write length as it depends on the width. So that's what I've done here, okay? The perimeter, the amount of fencing she has is 100 meters. I think I used meters. So the perimeter of this enclosure, now it's against the side of a barn wall, so we're not using this side, but the width of the enclosure is x, and the length is just this side. So the length, as it depends on the width, is, well, 100 is 2x plus the length. So the length is just 100 minus 2x. That's all I was looking for. The length of the enclosure, this is 100 minus 2x. You have 100 meters of fencing to use. Well, if you call this x and this x, you take away the two x's from the total. You have 100 minus 2x left for the length. Okay? So now it asks you to write area as a function of x, as a function of the width. So area of a rectangle is obviously length times width. That's why I kind of made that face. I'm like, yeah, you know this. But the area as a function of x then will be written as the length, which in terms of x is 100 minus 2x, times the width. So here you have area as a function of just x. There's only one independent variable. Okay, now it says to graph the area function. Well, to graph this, we are just graphing this, right? You could, if you wanted to, expand this to, and put it in descending order, negative 2x squared plus 100x, okay, if that helps you. You can do that. These mean the same thing, right? But for me, I like it factored. This is already factored, 100 minus 2x times x. Okay, and just remember, guys, that when you're finding the x-intercepts, if you're trying to graph this quadratic, you want to know a bunch of points, right? You can make a table, but the most important points are the intercepts and the vertex, okay? So from this point here, maybe you find the vertex. It's one thing we could do, right? But from here, maybe you see, okay, maybe you're solving the equation 0 equals 100 minus 2x times x to find the x-intercepts, right? Well, if you do that, it's already factored for you. You get x equals, well, if this factor is 0, you get 50. And if x itself is a factor, you just get 0. So 0, 0, and 50, 0 are two of your x-intercepts. So it's kind of nice to go from the factored form. Okay, let me make sure this is still on the screen. Yeah, if the problem is factored, you know 0 and 50 are your two x-intercepts. Another way to find the vertex, yet another way, is just to take the average of those two. The vertex is going to happen halfway between these, right? So the line of symmetry, the axis of symmetry, is x equals 25. Okay? So then if we plug in 25 into the function, we can find the vertex, the coordinates of the vertex, and we get a pretty good graph. It didn't specify how specific we needed it to be with the graph, so I think a vertex and these two x-intercepts are probably good enough. Plug in 25, which is the line of symmetry, plug that in for x, because the vertex happens somewhere along that vertical line, into either form, and we're going to get, let's use this form. 100 minus 50, right, times 25 is going to be 1250. Okay, so 1,250, where x is 25. Let's say that's somewhere up here. We don't know the scale, but we can make a scale. That point there is 25, 1250. So the graph goes like this. You knew the vertex would be a maximum from the first place because of the fact that the lead coefficient is negative, right? So all I've done for this problem is really the hard part, I think, is writing the area function, writing area as a function of x. So it's length times width. All you have to do is figure out the length in terms of x, depending on the problem. All right, write the area function. Okay, and then I didn't even use this standard form. I mean, you could have done the opposite of b over 2a to find the vertex. I did not. I just went with the two x-intercepts, which turn out to be 0 and 50, and then found the midway point, x is 25, and then plug that in to find 1250. Now, this is area, right? The y-axis is really the area axis, and this is x. So the answer to the whole problem, we're trying to find the maximum possible area of the enclosure, and the answer is 1250. Okay, the y value is the area, right? Area is a function of x. So the answer is 1250 square meters. I believe it was in meters, right? Did I get that right in the first place? I side with the metric system, so I believe yes. Okay, so that's it. 1,250 square meters is your answer. All right, so this is one application of quadratics. All right, just want to go through that with you one time. We'll do other more simple applications in class. This one's a little challenging, but I wanted just to show it to you in case you see it on the test.